You have built a high-performance ASP.NET Core application on your local machine, and now it needs to be shared with the world. The goal today is to take that isolated local project and get it running on a public cloud server, complete with a live web address. Before we start, you need 3 things ready to go: a completed ASP.NET Core project, Docker installed on your computer, which is a tool that packages your code into an isolated environment, and an active account with a major cloud provider. Running your application on a cloud provider means you only pay for the exact computing power you consume, and you inherit the provider's built-in enterprise-grade security infrastructure. Instead of your application living entirely on your hard drive, it becomes a scalable system that anyone in the world can access. We need to prepare your code before we even log into a cloud dashboard. A local environment is very different from a production server. This split screen shows an IDE. On the left, database passwords are typed directly into the code, a major security risk. On the right, those passwords are replaced with environment variables, safely pulling sensitive data at runtime instead of saving it in files. Next, you need to enable robust application logging. When running on a remote server, logs are the only way to read error messages and track down bugs. To ensure your application behaves exactly the same way in the cloud as it does on your laptop, we wrap the code and all its dependencies into a Docker container. This flowchart illustrates a continuous integration and continuous deployment, or CI/CD, pipeline. It automates your release process so that every time you update your code, it moves through automated testing and directly onto your cloud server. By securing your credentials, containerizing the environment, and automating the deployment steps locally, you prevent the application from crashing the moment it goes live. Now you can choose your deployment path. The major cloud platforms each have a specific workflow designed to get an ASP.NET Core app running quickly. If you are using Microsoft Azure, start by opening your dashboard, navigating to the App Services section, and creating a new service instance. During setup, you must select the exact .NET Core runtime stack that matches your local project. Finally, use the zip deploy feature to push your application files and manually enter your database connection strings directly into the Azure portal's configuration menu. If you choose Amazon Web Services, or AWS, the process starts in the Elastic Beanstalk dashboard, where you will create a new web server environment. Just like in Azure, you have to specify your framework by explicitly selecting the .NET Core platform from the provided drop-down menus before proceeding. Once the environment is ready, upload your packaged zip file and map your secure environment variables directly inside the Elastic Beanstalk console. Both Azure App Service and AWS Elastic Beanstalk handle the underlying operating system and server maintenance for you. You provide the application files and the correct settings, and the platform handles the rest. This workflow for Google Cloud Platform takes a container-first approach using Google Kubernetes Engine, or GKE. First, you upload your local Docker image directly into the Google Container Registry. Then, terminal commands pull that image and distribute it across your GKE server cluster. Getting the code onto the servers is step 1. Step 2 is opening your provider's monitoring dashboard to watch how the application performs in real time. Here, you will configure your auto-scaling policies. This tells the cloud provider to spin up additional servers if your application gets hit with a sudden spike in traffic. When you combine the initial deployment with active monitoring and auto-scaling rules, your application can detect traffic surges and adjust its own resources to stay online. Now it is time to test the system. Take the generated URL, paste it into a browser, and hit enter. If the application loads, your local environment variables, the server's runtime stack, and the network routing are all communicating perfectly. If it crashes or returns an error, open your provider's application logs to read the exact failure point and double-check your environment variables for missing values or typos. Before you log off, set up a budget alert in your billing dashboard to cap your spending and verify that your provider's basic security firewalls are active. Getting your application live on the web is complete. By reviewing your logs, managing your security limits, and monitoring your resources, you ensure the code remains functional and cost-effective over time.